A very warm welcome everyone. Today in this class, we will be studying Unit 16, Chapter Gases under Science and Technology, Class 9. I hope you all are prepared with every material that you need like your notebooks and pens because today we will be studying about oxygen gas. As I mentioned earlier, Earth is surrounded by atmosphere and the atmosphere contains many gases, and among which oxygen is found in the second highest amount in the atmosphere, that is about 21%. It is also very essential for us human beings because we take in oxygen and through the process of respiration we form energy. Animals also does the same, so does the plant. So it is very crucial for our survival. It is also found in organic compounds like carbohydrates, proteins, fats, and woods, and some inorganic compounds like calcium carbonate, silica, and water, which is also very crucial for our survival. In water, in each molecule of water, there is one atom of oxygen present. So, oxygen is very important for our survival. Now, let us study more about this very important gas. So, introducing oxygen. Oxygen is represented by the symbol O. The atomic number of oxygen is 8, and as I mentioned earlier, atomic number is the number of proton that is contained in the nucleus of one atom of an element. Since the nucleus of one atom of the oxygen has 8 number of protons, that's why the atomic number of oxygen is also 8. The atomic weight of oxygen is 16. The atomic weight is the sum of the number of protons and the neutrons contained in the nucleus of one atom of an element. Since oxygen has 8 number of neutrons and 8 number of protons, so 8 plus 8 is 16. That's why the atomic weight of oxygen is 16. Now the molecular weight. The molecular weight of oxygen is 32. So, why is the molecular weight of oxygen 32? It is because the single atom of oxygen is unstable. So, it shares the 2 electron present in its outermost shell with another oxygen atom. Here you can see that 2 oxygen atom is sharing 2 electrons each from its outermost orbit to reach the stable octet state. So here you can see that one atom of oxygen has 8 electrons in its outermost orbit and the another also has 8 electrons in its outermost orbit. So both of the atom is stable. So that's why oxygen combines, 2 atoms of oxygen combine to form a diatomic molecule to reach a stable state. That's why what happens is molecular weight is the sum of the atomic weight of individual atom present in the molecule. So, since the molecule of oxygen has 2 oxygen atom, so atomic weight of one oxygen is 16 and the atomic weight of another oxygen is 16. So, 16 plus 16 is 32. That's why the molecular weight of oxygen is 32. And you can see that since oxygen shares 2 electrons to form a bond, that's why 2 atoms of oxygen is combined with 2 bonds. That is double bonds. Similarly, as I mentioned while I was teaching hydrogen as well, hydrogen is also a diatomic molecule, and the nitrogen which we will be studying in the next class is also a diatomic molecule. Similarly, chlorine and fluorine also exist in the similar state. Now the valency of oxygen is 2. Valency is the combining capacity of an element with another element or radical. Since oxygen shares 2 pair of electrons in its outermost orbit while it is performing a chemical reaction. That's why its combining capacity is 2, hence the valency of oxygen is 2. The density of oxygen is 1.43 kg per meter cube. Now let us study a little bit of history of oxygen gas. So, British scientist Joseph Priestley prepared oxygen for the first time by heating the red oxide of mercury, that is HGO, in 1774. Later, Lavoisier named this gas as oxygen, which means acid forming. Oxy means acid, gen means producer. That's why he named this gas as oxygen. There are various methods to prepare oxygen gas. Now, to which method is the best among the others? There is 3 basic points that you must remember, which I explained to you in the while teaching hydrogen gas as well. It should be inexpensive, the rate of reaction should be moderate so it can be controlled, and it should be simple to prepare so that students like you guys can also prepare it by yourself in the laboratory. So taking all this point into consideration, there are 2 methods from which we can prepare the oxygen in the laboratory. The first one is without using heat and the second one is by using heat. So to prepare the oxygen gas without using heat, what we do is we take hydrogen peroxide, and in the presence of the catalyst manganese dioxide, hydrogen peroxide is decomposed. That is, it is broken down into water and oxygen. How this happens is, so hydrogen peroxide is H2O2. So it decomposes in the presence of the positive catalyst MnO2. This MnO2 is a catalyst, that is, it promotes the decomposition of hydrogen peroxide. So this hydrogen peroxide decomposes to form water and oxygen gas. Now this equation is not balanced because here you can see there is 3 atoms of oxygen and here is 2 atoms of oxygen. So let's write 2 over here. So there is 4 atoms of oxygen. If we write 2, there is 4 atoms of oxygen in this side of the equation as well. So oxygen is balanced. Now let us check hydrogen. Here is 4 atoms of hydrogen and here is also 4 atoms of hydrogen. So this reaction is balanced. So using this reaction, we will synthesize oxygen gas in the laboratory without using heat. Now let us prepare oxygen gas in the laboratory. At first, we'll try to produce oxygen gas without using heat. For that, the chemical required are hydrogen peroxide, which I have poured it in this bottle, and the catalyst that we will be using is manganese dioxide, which is taken here in the petri dish. Now these are the apparatus that we will need. The first one is round bottom flask, thistle funnel, and the delivery tube, which we have already bended according to our need, beehive shelf, gas jar, water trough filled with water. Now let us set up all these apparatus. Now let us pour this catalyst manganese dioxide into the round bottom flask. Now the manganese dioxide is already placed inside the round bottom flask, and we will pour hydrogen peroxide. Now we have not placed the gas jar yet because all the air trapped in this will get mixed with the produced oxygen. So we don't want to collect that impure gas. So we will let all this air pass out for a while, then only collect the pure oxygen gas. Now the tip of the thistle funnel should be entirely dipped. The tip of the delivery tube should not be dipped because the oxygen that gets collected should be able to pass through the delivery tube and reach the water trough. Now you can see that the oxygen has started to be produced. Now we will start collecting the pure oxygen gas because the air mixed oxygen gas has already gone out. Now when we are going to dip the gas jar, we should entirely immerse it and then only take the cover slip out. Now you can see that the oxygen gas is being produced, and the oxygen gas is getting collected by downward displacement of water. The gas jar is entirely filled with oxygen gas. Now to confirm if the gas we synthesized is oxygen or not, we will light a candle close to it and see if the flame brightens up or not. Now you can see the flame. Now the flame brightens when it is placed close to the gas jar. Why? Because oxygen helps in combustion, so the flame brightens. Now we confirm that the gas we synthesized is oxygen gas. Now we already prepared the oxygen gas in the laboratory without using heat. So using this reaction, that is the decomposition of hydrogen peroxide into water and oxygen, we just synthesize the oxygen in the laboratory without using heat. Now by using heat, we can again decompose potassium chlorate in the presence of the same catalyst, that is manganese dioxide, and if we apply heat, then oxygen gas can be produced in the laboratory. Potassium chlorate, KClO3, is decomposed in the presence of catalyst MnO2. This catalyst enhances the decomposition of potassium chlorate into potassium chloride and oxygen gas. Now this equation is not balanced. Here there is 3 atoms of oxygen, here there is 2 atoms of oxygen. So if we write 3 over here, then we have 6 atoms of oxygen, and here 2. Then there is also 6 atoms of oxygen. Now potassium and chlorine, there are 2 atoms of potassium and chlorine each. But here there is single atom of potassium and single atom of chlorine. So if we write 2 over here, now the equation is balanced. Now using this equation, that is decomposing potassium chlorate in presence of manganese dioxide, let us synthesize this gas, that is oxygen gas, in the laboratory by applying heat. Now we will again synthesize oxygen gas, but this time with using heat. Now to prepare oxygen gas in the laboratory by using heat, the chemical required are the catalyst manganese dioxide, which you can see I have poured it here, and the another reagent is potassium chlorate. Now the two reagents should be taken is 4:1 ratio, and I have taken it in 8 grams of KClO3 and 2 grams of manganese dioxide. Now these are the apparatus that we need to produce oxygen gas in the laboratory using heat. The first thing is the source of heat, that is the spirit lamp, clamp stand, beehive shelf, gas jar, water trough filled with water, hard glass test tube. We should use hard glass test tube, not the normal test tube, because this can withstand high amount of heat, and the delivery tube that is bent according to our need. Now let us take the chemicals we have poured previously, that is in the ratio 4:1. Potassium chlorate 4 and manganese dioxide 1, 4:1. So that's why I've taken it in 8 grams and 2 grams respectively. Now let us mix this in hard glass test tube. Now let's mix this two chemicals. Now after mixing this, now let us set up the entire setup. Now let us heat this. We are using tripod stand just to elevate the height of the spirit lamp. I have not placed the gas jar yet, even though the oxygen gas has been synthesized, because it is impure right now, because the air that is already present in the hard glass test tube is mixed with the produced oxygen. The second precaution you should keep in mind is the gas jar should be completely filled with water. And while placing the gas jar, you should first insert it completely, then only remove the cover slip. Now you can see that oxygen gas is being collected by downward displacement of water. Now you can see the gas jar is completely filled with oxygen gas. Now to confirm if the gas collected here is oxygen or not, we will again do the flame test. That is, if the flame brightens up when we place it near the gas jar, then the produced gas is oxygen. As you can see, it brights up. So the produced gas is oxygen gas. Now as you saw that we have prepared oxygen gas in the laboratory by two methods, without using heat and by using heat. Now let us look through the chemical as well as physical properties of oxygen gas in the classroom. Now we just synthesized oxygen again in the laboratory by the decomposition of potassium chlorate in presence of manganese dioxide and heat. Now let us recall all the precautions that we just took while preparing oxygen gas in the laboratory so that there won't be any accident when you guys will try to synthesize it by yourself. The first precaution is all the apparatus should be washed and dried well. Pure manganese dioxide should be used. Why? Because manganese dioxide is a positive catalyst. It is used to increase the rate of the reaction. If pure manganese dioxide isn't used, then it might not increase the rate of reaction to our liking. That's why pure manganese dioxide should be used. The another point is the apparatus should be airtight. I already explained to you while preparing hydrogen gas how we can seal the apparatus using candle wax. So that's why I did not show you that step while preparing the oxygen gas in the laboratory. So all the apparatus should be airtight, and for that you can use candle wax. Another precaution that you must remember is the tip of the thistle funnel should be entirely dipped. Why? So that if it is not dipped, the produced oxygen gas might escape from the thistle funnel. So to prevent that, it should be entirely dipped. But the tip of the delivery tube should not be entirely dipped. Why? So the produced gas will have a path to transfer so that it can get collected in the gas jar. Another point is the gas jar should be completely filled with water. If it is incompletely filled with water, the incompleteness will be covered by the air. So the produced oxygen gas will get mixed up with the air and we will not be able to obtain pure oxygen gas in the laboratory. So you must remember that the gas jar should be completely filled with water. Now let us recall the test of oxygen gas, how we did it in the laboratory. So since we know that oxygen gas is a supporter of combustion, so when we place the candle close to the jar containing oxygen gas, the flame brightens up because oxygen supports combustion, and since the candle is burning, so it supports that combustion, so the flames brighten up as we saw in the lab while we were testing oxygen gas. So this is the test of the oxygen gas. Now let us study a little about some physical properties of oxygen. The first is, as you saw while we were preparing the gas in the laboratory, the gas did not have any color. So the oxygen is colorless. It does not have any smell, so it is odorless, and it has no taste. Hence it is tasteless. So oxygen is colorless, odorless, and tasteless. The another property is the oxygen gas is slightly heavier than air and it is partially soluble in water. So there comes one important question, that is, how is oxygen collected by the downward displacement of water? And the answer lies in two main physical properties of oxygen. Can you guess that properties? Yes, you're right. The two properties is it is lighter than water. Since it is lighter than water, as you can see in the figure, oxygen gas rises up and gets collected in the gas jar and it displaces the water downwards. And it is slightly soluble in water. So since it is only slightly soluble in water, some of the oxygen gases, that is many of the oxygen gases, can rise up and it displaces the water downward so that it can get collected in the gas jar, which you also saw in the laboratory. So, due to these two properties of oxygen, oxygen gas can be collected by the downward displacement of water. Now, the another property is oxygen gas does not respond to litmus paper. That is, it does not change the color of litmus paper, be it red or blue. Since it does not change the color of the litmus paper, we can say that oxygen gas is a neutral gas. And the final physical property that we will study is oxygen changes from gaseous state to liquid state at the temperature of about minus 183 degrees centigrade, and it changes into solid state at the temperature of about minus 219 degrees centigrade. Now let us study some chemical properties of oxygen. The first chemical property we'll study about is oxygen when reacts with metals, it forms metal oxide. So metals such as sodium, potassium and magnesium. So when oxygen burns with metals such as these, it forms metal oxide, whose reaction you can see here in the screen. So, oxygen reacts with sodium to form sodium oxide, with potassium to form potassium oxide, and with magnesium to form magnesium oxide. Similarly, when oxygen reacts with non-metals, it forms non-metal oxide. Previously what we said, when oxygen reacts with metals, it forms metal oxide. But here the second chemical property is when oxygen is burned with non-metal, it forms non-metal oxide. So there is one major equation, that is one major reaction with non-metal, which is very important for our survival. That is, when oxygen reacts with hydrogen, it produces water. So hydrogen and oxygen, when they react, it forms water. Similarly, another non-metal such as carbon, if it reacts with carbon, it forms carbon dioxide, and if it reacts with sulfur, it forms sulfur dioxide. Now the another chemical property is when hydrocarbons are burned in the presence of oxygen, it gives us carbon dioxide, water and energy. So what is a hydrocarbon? From the name itself, we can understand what it is. So hydrocarbon are compounds that contain hydrogen and carbons. Some of the examples are methane, ethane, propane, etc. And here we will see the reaction of methane and ethane. When methane burns with oxygen, it gives us carbon dioxide, water and energy. Similarly, if it reacts with hydrocarbon ethene, it gives us carbon dioxide, water and energy as well. Now let us study about the another important chemical properties of oxygen. So when we eat food, the food is stored in form of glucose in our body, and when we perform breathing, we take in the oxygen, and that oxygen through the process of respiration gives us energy, and this is the process of respiration. That is, the oxygen that we breathe in will break down the glucose into carbon dioxide, water, and this energy will help us to perform our day-to-day activities. So this process of respiration, which includes oxygen, is crucial for our survival. Now the another chemical property is when alcohol burns with oxygen, it also gives carbon dioxide, water and energy. Here you can see one example. When ethyl alcohol is burned with oxygen, it gives us carbon dioxide, water and energy. Now let us study about some uses of oxygen. So I already mentioned this in the chemical properties. We living beings use oxygen gas to produce energy by the process of respiration, and that energy is used by us to perform our day-to-day activities. Oxygen is used along with hydrogen. This point I have already explained to you in previous class as well, while I was teaching you hydrogen gas. Oxygen and hydrogen forms oxyhydrogen flame that is used to cut the metal or weld the metals together. In some patient who has difficulty in breathing by themselves, oxygen is given to them through a mask, which is also known as artificial respiration. So oxygen is also used in artificial respiration for patients who are suffering from difficulty in breathing. Another use of oxygen is if we have to travel to some places where there is absence of oxygen like space, the astronauts takes oxygen cylinder and breathe in oxygen from that cylinder. Similarly, when you are climbing the mountain, what happened is as the altitude rises, the amount of oxygen decreases. So the people who climb the mountain carry oxygen cylinder with them. So when they feel like they cannot breathe properly due to lack of oxygen, they take in oxygen from the cylinder. And since we human beings cannot breathe underwater, we carry oxygen cylinder while we are diving down in the sea so that we can breathe in inside the water as well through the oxygen cylinder. Another use of oxygen is used to manufacture steel. Now, from all this knowledge, let us try to test ourselves with one question. That is a statement. The burning of hydrocarbon and alcohol produces the same product. Argument 1. In both the cases, products are carbon dioxide and water with the release of oxygen. And the argument 2 is, in both the cases, one of the product is water. And these are the option from which you should choose the correct answer. So now let us study statements and arguments one by one. So the burning of hydrocarbon and alcohol produces the same product. Is it true? Yes, it is true, because I already explained to you during the chemical properties of oxygen that when hydrocarbon is burned with oxygen, it gives us carbon dioxide, water and energy. Similarly, when alcohol is also burned with oxygen, it also gives us carbon dioxide, water and energy. So the statement is correct. Now argument 1. In both the cases, the product are carbon dioxide and water with the release of oxygen gas. Is it true? No, it is not true. Why? Because oxygen gas is used for the reaction itself. But what is released? Energy is released along with carbon dioxide and water in the both cases. So, the argument 1 is incorrect. Now, argument 2. In both the cases, one of the product is water. Is this true? Yes, it is true. From the reaction here also you can see in both the reaction one of the product is water. So the answer is statement 4. That is, both the statement and the argument 2 are correct. Now I would like to give you a project work that you must do. So the project work is you have to observe various ways in which oxygen is being used around you, and you have to write how the oxygen is being used and why we are using the oxygen for that purpose, and you should also list out the benefit we can obtain from its use. So I'll show you one example that I have prepared so that you can follow that to do this project work. Okay, this is one example that I observed, that is while cooking. So how this oxygen gas is being used? The carbon that is contained in the wood and the carbon and hydrogen that is contained in the LPG gas, it reacts with oxygen, and on burning it releases heat energy. So why this oxygen is being used is oxygen gas supports combustion. That's why we are using the oxygen gas for this purpose. And what benefit do we obtain is when burning carbon and hydrogen, it releases heat energy. So to produce the sufficient amount of heat that can be used for cooking our food, we do this. So that is the benefit that we obtain, that is sufficient amount of heat is generated that can be used to cook our food. So following this pattern, you have to write 4 examples and you can then discuss it with your friends and show it to your science teacher. I hope you all understood what I taught today, and make sure you do the project work and discuss it with your friends and show it to your science teacher. Now I'll see you guys in the next class.